Okay, cognition, cognitive dissonance. Cognitive dissonance as a tool for learning. Zen, koan. What is the purpose of a Zen koan? To put a mind into cognitive dissonance. That doesn't make any sense. That's nonsense. But your mind chews on it anyhow. How can I make sense out of it? What does my master, what does my guru, my whatever, my mentor mean by this? None of the koans come to mind, so you'll have to go find your own koans. That's basically what a koan is. By putting the mind into cognitive dissonance, it has to grind on it until it's got to deal with it, till it gets to the point where you let go. That's pretty much a big part of what Zen is. Let go and just be. So a machine mind should be able to use cognitive dissonance as a learning tool, not only exception handling when it finds something that doesn't fit, um, but rather the system can seek it out. It's part of its self-learning process. Try to find things that cause cognitive dissonance. So we've got cognitive dissonance. What's cognitive dissonance? Cognitive dissonance is this cognitive unit and this cognitive unit not making sense to the mind. Right? The two together don't make sense. So how is that dealt with? Well, I guess one, has the mind learned something? Well, of course it has, because everything is learning. Everything's a lesson. So just by putting effort into something, the mind will learn something. So you've got this red cognitive unit when tried to be joined or merged or linked with comfortable, nice. Oh, I know this. I Anyhow. So the mind's going to have to see. I've switched sides. Decide. Do a Tosh detector. It needs to decide. This is nonsense. I don't care. Disregard it. Versus, oh, okay. You're getting back to the picture example. Um, you're talking about a dog, but that doesn't make any. Okay, here we go. How about the case study of the machine mind learning that even though it calls that a dog, does that mean a dog has to be a wolf? If the machine mind can't get to the point of saying, um, this is what I know of as being a dog, say a golden retriever, like my dog Uli. Um, so we know wolf, but we're trying to apply it, but we know that a wolf's a dog. So we have a golden retriever, say a picture of my dog, Uli, and that causes cognitive dissonance because for whatever reason and state, the machine mind doesn't recognize a golden retriever as a dog. It doesn't learn that yet. So how does it handle it? Well, in this case, it's not Tosh. The incoming actually is like an image of a dog. So this is an opportunity to learn. And this should be a very simple use case, actually. Um, because with a little machine vision capability, Again, Helen can like go to Google or whatever and search on dogs. I think I already used this example, but and get a set of dog images and then process those. And so, and again, patterns within patterns, pattern matching is what makes everything work. So, you know, it starts, well, first of all, it checks the data set and finds a match for what it's trying to cognitively, what's the opposite of dissonance? Sense? Positive sense? I don't know. It's learned. Saying, oh, I found a match. And my data set, Ole, please. My data set says, okay, according to this data set, that's a dog called Golden Retriever. So it does its thing to put it into the system so that now it's knowledge. Now it knows. Now, next time, the cognitive dissonance doesn't happen because it says, oh, yeah, that's a dog. Yeah, sure. I'm jiggy with it. But there's more opportunity here because Helen can also analyze the other pictures in the data set and possibly learn about Shiba Inu and Great Pyrenees and stuff like this, right? It didn't know to go out and look for it, but here I'm asking, my cognition isn't up to recognizing this incoming image or thing or whatever. Um, it doesn't know to go ask and say, "Hey, is Great Pyrenees a dog?" See here we're getting it from a different angle. Um, it's got a source telling it, well, here's a Great Pyrenees, here's the Shiba Inu, here's a Lhasa Apso. Um, and so it stores that. It doesn't know it for sure because you don't want the system doesn't want to be gullible. The for whatever reason Google returned a picture of a human. Oh, a human's a dog. Wow. So it's looking at an image of a human and says, "Oh, that's a dog." Wrong. We don't want the system thinking of humans as dogs. Totally different ontologies. So confidence. It puts for future recognition the Great Pyrenees and the Shiba Inu into itself, and then it knows to go out and ask like Wikipedia or something. Tell me more about Shiba Inu. Ontology context is animals because Shiba. I own a lot of Shiba Inu. It's also an altcoin in cryptocurrency, a meme coin as they call it, a spin-off of Doggy. I don't call it Doge. I'm pretty sure the originators meant for it to be pronounced Doggy because look at the never mind. Look at the picture though. It's a dog. Dog E. It's some idiot like Elon Musk that changed it to Doge or because they liked the sound of that better. Anyhow. Um so next time so so yeah, it's given it an opportunity to learn. But say it's a human, not a dog, not a monkey, Dave the Barbarian. How does it handle it? Well, I guess it would make a query. That's a better way to put it than keep mentioning Google. Make a query to a SQL database or whatever. Ultimately, that's how things will be implemented, at least in the early versions. But so Helen's not very confident about these other things that evidently qualify as a dog. So, and again, that we were working with a higher ontology of animals, boop, 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 dog, as opposed to some slang or something, a human derogatorily calling somebody else a dog. Oh, you dirty dog or whatever, right? Uh, Discernment. A machine mind needs to be able to discern. Okay, 11.